Hello everyone, and welcome to another Hibernate in Rhinos webinar, this time talking about RavenDB 2.5. We actually released RavenDB 2.5 almost 6 weeks ago, but we tried to make this silent launch, mostly because we wanted to get feedback from people about the new code and how it's working, before we make a big fuss about it. Well, turn out we didn't really have to wait so long, but I think it was the right decision because we just released build 2700 and we got some really great feedback from people about how it's working and the kind of experience that they had with RavenDB. RavenDB actually represent about 2.5 actually represent about 6 to 8 months of work by our team. And before we get any further, I just want to mention two things that literally happened the past couple of days. We had 2 RavenDB books coming out. RavenDB High Performance by Brian Ritchie. I actually wrote the foreword for that, and I was involved in the technical editing of the book, and I think it's a great book that covers a lot of the non-fundamentals. So after you created a document store, after you put some stuff into RavenDB, I think that these books really handles well what's next. Not just, okay, I put some data into RavenDB, I get some data out, but all of the actual details about this is how you build a RavenDB application, and this is how you build a RavenDB application at high performance. The other part is RavenDB 2x beginner guides, and I wasn't involved with this book almost at all. It actually obviously covers the basic and how to go over that. So that's even newer than 2.5. And let's talk about 2.5 itself. As I mentioned, 6 to 8 months of work. And we actually took the time to do a whole bunch of really interesting stuff that you probably won't even pay attention. A lot of the stuff that we did was related to indexing and how indexing works, and a whole bunch of changes related to that is fascinating to look at, and in aggregate that generate some pretty major improvement to our performance, but all of those changes are relatively minor in isolation. We also did a lot of performance work, and we have a whole bunch of really nice features. So let's start taking a look. So the first thing that you probably notice when you open RavenDB 2.5 is that the studio had a tiny facelift. So a tiny facelift means that we are now better able to work with, one second. So a tiny facelift means that we now, seriously, okay, apparently I'm unable to log into the studio, which is annoying because it happened during the live show. Let me try it again. Yeah. Okay, that makes sense. And everything, and let's start from scratch. Anyway, so while we're waiting for me to remember what my password is, I wanted to mention a few of the things that we did. Basically, people started shoving ton and ton of really interesting stuff into RavenDB. That means we had people that had a lot of collections. We had people that had a lot of databases, a lot of information in those databases. So this is the new studio. You can see that we merged the documents and collection tabs, and now they're all in one place. I think that's much, no, we don't want to go over that. So, by the way, this is production data. You can see it from blog.iendo.com. This is what drives it. We're currently running build 2705. Again, we are following the rule of eat your own dog food. So we're actually working on that, on the absolutely latest edition. This is actually from this morning to make sure that we actually give you the really good experience that we strive for. So let's take a minor look around. So here is a small thing. If you want to look at indexes, you don't have to go to the index page. You can more easily look at those things, look at multiple documents, compare them, those sort of things. So that's nice. Other things that we have done is we made patching easier. So patching is a feature that came in 2.0. This is now much easier to work with. I will show you this in a bit. Basically, we had too many tabs. So we used the Chevron stuff, and that's about it. You know what? Let me show you this. Statistics got a bit of a boost. We have better information in here. More importantly, let me do something that you shouldn't be doing. Again, you can see that we give you more information about those indexes. So here I have an index. I don't know what it's about, but here you can see that I have an index that is colored differently. This is because no one is probably using this. So this is indication, look, you can delete this guy. And it's gone. I probably should not be doing maintenance at this point in time, but who cares? Let's see. So there is stuff. But let's do something that's actually interesting. Let's look at this one. And now you can see that I have this number, 116. This is the number of index entry that we have in the index. For that matter, I'm going to reset this index, and then I'm going to go into the statistics and look only at that index stats. As you can see, now we're basically forcing RavenDB to recalculate all of the tags in my blog. So we have about 17,000 documents in this database, and it's going to take a bit of time to do so. And now you can see another nice improvement. And I'm sorry, the screen is really too small to see it, but you can see that we started by indexing some documents, and now we start applying the MapReduce rules, blah, 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 blah. Okay, and we're done. I think we're done. Yeah, looks so. So this is the studio. I don't want to get held up too long over the studio. We've done a lot of work there, but as you can tell, this isn't really what I care about. This isn't what I do RavenDB for. So unbounded support. From the get-go, RavenDB had the notion that we wanted to be safe by default. Safe by default means that we don't want to give you the gun to shoot your own foot off. So one of the things that we did was we ensured that you don't have to worry about unbounded result sets. That meant that every operation that you did against RavenDB had a page limit set upon it. And overall, that was a really good decision. I think that it really helped us create a really good product, because we got several responses from people. Look, we tried this, it stopped us and it saved us. The other side of that is that we really needed a way for the actual cases where you do need all of the results. So this is now up in 2.5, unbounded results. You can see that we have a dedicated API. At the same time, as you can see right here, you have the ability to actually do that using link. You have the ability to say, okay, I'm going to create a link query, and then I'm going to pass it to a stream and get all of the results back. And I think that's a very powerful option that you have. By the way, you also have the ability to do paging on this. Now, interestingly enough, this isn't just a random decision from the point of view of the API. You can see that streams are baked very deeply into how we work. And the streaming API is streamed both on the client and on the server. What this means in turn is that there is nowhere in the entire process where we need to aggregate 100 million results before we start sending stuff to you. That means that we send stuff to you as soon as possible. As soon as something is ready on the server side, it gets sent to the client, and it's immediately surfaced to you. Interestingly enough, that means that if you have a very long operation, if you have a very large data set, that team can take a while to just, get down there. And then you have the processing for it that also takes time. So now the question becomes, what happens if there are modifications during that time? And the answer to that is that this is a transactional operation. That means that you see the state of the database as it was at the time of the beginning of the operation. If someone went ahead and deleted a bunch of documents or inserted a bunch of documents or updated those documents, you see those documents as they were at the time of the initial query. So you don't have to worry about concurrency. It just works for you. I want to open the floor for questions as we go along. You have the ability to ask questions or raise your hand. If someone wants to have some back and forth, I would love to have that. Anyone have any questions about the studio or about the unbounded support that we have? I give it another few minutes, few seconds actually. Going once, going twice. There'll be no questions. Let's move on. So, next thing. Oh, wait, we do have questions. So, Lance Harper is asking, is the studio likely to remain Silverlight-based for the foreseeable future? And the answer for that is no comment. Speak to us in a couple of weeks. I'm sorry you're doing that. We have a webinar in a couple of weeks that is called RavenDB 3.0 Mystery Feature, and that's all I'm going to say right now. Any additional questions? Going once, going twice, and moving on. So, for a long time with RavenDB, we had Xcopy installed. That meant that we gave you a zip file, and you extracted that, double-click the software, and it just worked. However, we got requests from customers, especially big customers that want to automate the deployment of RavenDB, usually as part of unattended installs, that MSI is something that they really require. So we listen, now we have an MSI installer. As you can see from the image, actually, that's the wrong image. It's supposed to show something else, but as you can imagine from the image, this is a yes dear installer. That means that it will take your process through the installer process through all of the steps. If you want to run RavenDB as an IIS application, this is probably the easiest way to do so. If you want to set up RavenDB as a Windows service, easiest way to do so. So I really think that this is going to be an important feature, even though this is one of those taxes that you have to do. You know, no one likes to write installer, but as you can imagine, they're pretty important. Okay, next topic. Next topic, result transformers. Okay, so what are result transformers and why they are so important? I think already in 1.0 we had the ability to write a transform result inside the index. The ability to write some code that would operate at query time and would have the ability to do some interesting things. The problem with result transformer that were attached to the index was that it was attached to the index. And that meant that you only had the ability to choose use that result transformer or don't use that result transformer. And if you wanted to change that result transformer, it was attached to the index, which meant that you had to re-index everything. It also meant that you couldn't mix and match. You couldn't say, oh, I have this result transformer that I want to apply it to 3 different indexes. Or maybe I want to apply it on a load. So with 2.5, we wrote result transformers and we made them into a distinct entity, something that exists outside the boundary of boundaries of the index. And a result transformer is a piece. It behaves very much like an index, in the sense that you created in pretty much the same manner. You have abstract transformer creation task and blah, blah, blah. Notice that you can do interesting operation like load document in there. So you're not limited to just any old transformation. You also have the ability to touch other documents and pull stuff from other documents. Now, this gets interesting because now you can apply a result transformer to any index. You can even apply a result transformer to load operation. And that means that you suddenly have a lot more freedom. The trivial example is what happens if I want to have just enough information for a drop-down box, drop-down list. And that means that I only need the ID and the name. I can write a single result transformer and apply it everywhere I need a combo box, a drop-down list. And I can even apply it to different indexes, to different types if I really feel like it, because this happened in the server. So this is just a duck typing. So we can use the types on the client side, but mostly this is used to give you strongly typing and compiler. But we can take this, and assuming that we have another object with the same properties, this will work for those as well. Result transformer get picked up by the index creation call, so you don't have to. So basically, you don't have to change anything. You still have index creation call that goes and scan your assemblies and look for the appropriate classes. It execute them against the database and create them if needed. Questions so far about the installer and result transformer? Going once. Going twice. And okay, we have a question from Troy Zarger. Does result transformer stream? So it's interesting in the sense of what do you mean stream? Result transformers are applied at query time. That means that they are applied after all of the operation happen. That means that you don't have to call, so that means that you don't have to worry about page charges if you use them for standard operations. So they happen, what I'm trying to say is that they happen after the paging has been applied. However, so Troy is also saying, is the query still limited by 128 or 1024? And the answer is yes, because this happens server-side, but after the paging has been applied. However, you're absolutely free to combine a result transformer with streams. That means that you can actually have a result transformer that operates server-side over unbounded set. And that gives you the ability to do some quite interesting things. For example, you have the ability to do group by in a result transformer. And if you explicitly say, okay, I'm willing to accept the streaming cost of doing that, you can actually do that. Something else that you can do, you can even send parameters from the client side to the transformer. Tell it, oh, we are now doing X or Y or Z, so apply this logic or that logic, and so on. So that's it for result transformers. By the way, guys, I'm only doing a quick previews over most of those features, mostly because we had a time, one of the reasons that we didn't go public with RavenDB 2.5, the moment that it went into stable release, was that we wanted to take the time to do documentation properly. We have done so, and we have full documentation for working with result transformer on ravenDB.net/docs. Next topic, scripted index results. And this is actually something that is really, really cool, because one of the things that people kept asking us for is, okay, you have indexes and you have MapReduce. What we want to do is recursive MapReduce. Or I want to be able to include a result from an index. Or maybe I want to have a way of something people use triggers for in relational database. When X happens, then I want something else. When I add a new order line, I want the total numbers of item bought by a customer to be updated. All bunch of stuff like that. And scripted index results is our answer to that. Basically, it operates over the result of indexing. So the index run, and it outputs some sort of a projection. That projections then gives us the ability to do anything we want, basically. As you can see in the screen, what we're doing here is think about the NoteMint model, and we have count of orders per company. And then we go and load that company's document. And then we say, you know what? We're going to add the total and the count of items that we have from this order to that company document. Now, actually I'm sorry, that's not correct. What we're doing is we add the total number of orders and the total across all orders to the company document. Notice that that we have two scripts here. One is for what happened when we index something, what happened when we delete something. And that's it. The fun thing about it, using this, we can actually have a MapReduce index. Actually, what we have right now is a MapReduce index, but we can have a MapReduce index, and that MapReduce index can output using put document new results. And those new results can be picked up by another MapReduce document. Something that should be made obvious, you can't have the scripted index results output documents that will be picked up by the same index that generated them. If that were to happen, we will obviously have an infinite loop, and we want to avoid that. Questions so far about scripted indexes? Going once, going twice. and go. Okay, this is actually the part that I've been waiting for. This is where most of the interesting stuff happened. So as I mentioned, we've done tremendous amount of very small changes, and the aggregate result is something quite beautiful and much easier to work with. So with RavenDB 2.5, we now have the ability to index directly into memory. That means that as long as we're doing indexing on new indexes, we don't have any I/O costs. And the basic idea here is that this means that new indexes are able to catch up with catch up faster because they don't have to do as much. And 1 second, I think that we have Serjan that is raising their hand. I'm going to unmute him. Hello, Serjan. Can you hear me? Serjan?
Yes, I can hear you, Oren.
Hi. How are you?
Can you hear me?
Yes, I can.
All right.
Yeah, you had a question?
No, I just joined.
Okay.
Sorry if that's...
That's fine. So everyone say hello to Serjan and bye-bye.
Bye.
Okay. So let's move on. So we have indexing directly to memory. As you can imagine, speeds things up quite a bit. The next thing is that we have a really, really fun feature that is index merging. The query optimizer can now expand indexes instead of just creating new ones. Let's talk about what this feature is for. Let's imagine that we have a user document. And you know what? Let's actually do that. So we're going to go into our production system. And let's go and create a new database. And let's do something interesting. Pam, 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 pam. Maybe you shouldn't do stuff on production, you know? Yay. Okay. So let's see how it works. User/1, ONANY, email, okay. Now, I'm going to go and do a dynamic query on users. And let's see. What you can see here is that we have an auto/users by index. This is the same behavior as you would see in 2.0. Now, the interesting thing is what happened when we have and now look at this guy. So what we have done, RavenDB said, okay, I have to do an index on users by name. So we generated auto/users/by name. And then we had another query on users, and that query was /users/ and that query was for email. It wasn't for email and name. However, RavenDB looked at things and says, okay, I see that we have queries for users by email and for users by name. So I'm going to create an index that would work for both of them. Now, if I'm going to go here, you can see that I actually have both of them in here. However, this is going, if we're going to wait for a while, we'll notice that this index doesn't actually get any hits, and eventually we will delete it. And this one will be the index that survived because this is the bigger index. Apply logically, you can see that what happens is that RavenDB is now able to detect very easily what your indexes really should be, and according to that, it creates the optimal indexes. questions so far? While you're thinking about questions for this, I want to show you how this applies in real-world situations. And you can see that we have these two guys, and actually I think, yeah. So this is actually, I think, at the limit of what it's able to do, so that's why we have both of them. And same things here. Actually, we used to have lots more auto indexes for those guys, but let's see. You see this one here, and then you see this one here. And the reason that we don't have all of them in a single index is that we go into a tags and slugs as a collection. So we'll only we'll only merge indexes that share the same collections nesting. Otherwise, it's getting into all kind of weirdness that I don't want to deal with. But that's the reason why we have two indexes for posts. Same thing's probably in here. Yeah. Okay. So that gives us better performance, smaller indexes, and less cost overall. Yeah. Now, we also have, so another questions that, another request that we kept having was, can we have index priorities? And when people ask us for index priorities, my immediate response is, what do you want them for? And the answer is usually, oh, I have this slow index. And that's where we stop and handle the slow index versus handle index priorities. But there are actually valid reasons why you want index priorities. So we added them. Now you can see that we have some really interesting options for index priorities. We don't have high, low, medium, and stuff like that. We have normal, which means that we will try to get to this index as soon as possible. We have idle, which means this index is important to me. Index it as soon as you can, but only as long as there are no other work that you could be doing at this time. So if there are indexes that needs to be done, this can wait. It's not that important. Disable basically means don't touch this index. You can just ignore it. We don't care about it from now on. Abandoned means that, look, no one has queried this index in forever. That probably means that no one really cares about it anyway. So we are going to index that, but only once we have been idle for a long period of time. So now that I've explained those four priorities, I'm going to try to explain the logic behind them. Ideally speaking, we only touch idle indexes when we don't have enough work to do. That means that under normal operations, we'll touch them pretty much as soon as a document write happens, because we first have a chance to run all of the normal indexes, then we run all of the idle indexes. So under standard operations, you probably won't see a lot of difference between normal and idle indexes. Under load, however, you will see all of the normal indexes being updated as soon as we can, and the next batch that we try, we have more work happening for normal indexes. So we'll do that now. Idle indexes will happen when we actually have time to do so. Next thing to happen is, what about abandoned indexes? And abandoned indexes will not happen. They will only happen after we've been idle for a long period of time. If I remember correctly, the default time that we're talking about is about 3 hours. So again, normal circumstance means that during the day, assuming that you have a usual 12 hours active period and 12-hour dark period, that means that during the day you have lots of work on the system. Normal indexes are updated. Idle indexes are updated when we have a chance. Abandoned indexes aren't touched. Overnight, however, what will happen is that our database will say, I haven't seen any work for me in a while. That means that this is now the chance for me to do some work. Let's do all of those abandoned indexes. So this gives you the ability to say, okay, those aren't really important indexes. I can do them overnight. Note that this is not scheduling. If you have any process that write documents to RavenDB, that would stop that behavior. And that's intentional because abandoned indexes happen only when we actually have nothing else to do and we hadn't had nothing to do for a while. The logic is saying that if we are now, so for example, if we have people go on lunch break and suddenly have half an hour of no activity, that isn't actually the time to start doing all of the hard work that we need to do abandoned indexes. We only want to do that after we're pretty sure that no one is going to call us for the next few minutes or hours, depending on however much load you have on the system. By the way, again, we don't do all of that work all at once. It means that even if you have in the middle of your idle nighttime someone that goes into the system start doing stuff, we let the current abandoned batch run, which usually take up to a couple of minutes, and then we'll start processing normal indexes as usual. Questions so far? Anyone? Yeah, so we have Troy Zarga. If you have a very active server and indexing is mostly stale, would idle eventually be abandoned since it never had a chance to run? And the answer is no. Idle, so by the way, something that I haven't mentioned, by default, we will only apply or we will only decide that an index is idle or abandoned for auto indexes. Static indexes never get set to idle or abandon because you have explicitly created them. Only auto indexes are. However, the idea of an index being idle or the idea of an index being abandoned are tied to who queries them. So an idle index by default is an auto index that hasn't been queried in about an hour or so. If you have queries against that system, against that index, that means that it's not going to be marked as idle. It's going to be marked as normal and hurry up to catch up. The basic idea is that let's imagine that you have a very small part in the system, for example, that is only accessed every once in a while. And that part of the system is served by this index. Because it's only served once in a while, it's going to get set to idle. And until and unless the user is actually going to hit that page, we're only going to serve it as we have time. We don't have to serve it all of the time. The basic idea is again to get into that holy grail of auto-tuning, of being able to actually do everything automatically for you. More questions? Going once, going twice. Okay. Next feature that we did for indexing is another fun one, and this is lock-in indexing. Lock-in indexing is actually a pure production feature. What do I mean by that? Let's imagine that you have now gone into production and discovered for whatever reason that there is some problem with your index. Now, you can go into RavenDB, into the management studio, and update that index and fix the problem. And now everyone is happy. However, a very common practice with RavenDB is that on startup of the application, we recreate all of our indexes. This is a no-op if the index already exists in its current form in the database. We just say, oh, we already have that, and move on. But if that index has been modified by you, we're going to say, oh, that index is not the same version as I have. I'm going to have to recreate it to my form. And what happens then is that you fix the problem, and sometimes later the system restarts, your application recreate the old index, and you have the same problem again. That means that you could have fixed the problem by just doing an op change on the server, but now you have to do the full push to production with all of the associated costs for that. For example, you have to do new UAT cycles, new verification steps, etc., etc. So what we can do instead is to set those options. And those options basically says unlock index, which is the default, locked, ignore, and locked error. And what's the meaning with lock, ignore, and locked error? Locked ignore means that when we get a request to put an index for this index, we're going to say, no problem, I have done that, I've done whatever it is that you request, and lie to the caller code. This is when we have lock ignore. When we have lock error, we're going to actually say, oh, you requested this, but I'm going to say no, and I'm going to say no very loudly by throwing an exception. Note that this is not a security feature. Anyone with access to the database can lock or unlock an index. This is mainly to provide support for that particular scenario. Okay. Questions so far? While you think about new questions, I'm going to move on and answer as questions come along. So another thing that we have done, we have worked really hard on the prefetching algorithms that we have. Prefetching algorithms basically refers to the way that we load data from disk for indexing. In 2.0, we introduced the notion of prefetching, and what it really helped is by making sure that by the time we finish one indexing run, we had the data for the next indexing run available. In 2.5, we did even more work on that. Now we get to the point where we don't even have to hit the disk to do any indexing at all under normal circumstances. We can just do the entire thing in memory. That was another thing that really helped us for performance-wise in 2.5. Another thing that we did is basically refreshing the writer. This is mostly relevant for users who write tremendous number of documents in a short order. And what happens then is that we store some data associated with the writer to the index. If you care about, this is the Lucene index writer, and we want to keep it around for a long time. However, it also uses some memory when it does that, and honestly, under some really strange scenarios, it would get to the point where it would use too much memory for no good reason. So now we will be able to refresh that and release that memory. Obviously, this happened on a schedule that means that it only happened very rarely. If I remember, it happened only once every 250,000 writes or something like that. So you don't really have to worry about it for standard operations. Even more, we have more spatial API, better spatial API, support for a well-known text, support for shapes, all bunch of stuff like that. I would like to thank Simon Bartlett for doing a lot of that work there. We have faster SQL replication. We have been able to optimize the way that we are doing things. We're actually using prefetching, the same prefetching strategies in here as well to drain faster into the relational database. We made improvement for a distributed transaction, both in the performance of the system, both in how well we tie to the protocol. And we made bulk inserts report error faster. So in 2.0, if you did a bulk insert and there was an error, it would actually error, but you would only know about it at the end of the process. In 2.5, you will know about it the next time that you call store or do anything with the bulk insert object. Okay, this is an interesting feature slash I don't know what. Up until 2.5, we had a single writer lock per database. That meant that you can also do, you couldn't do real concurrent writes into RavenDB. With 2.5, we now allow you the ability to do actual concurrent writes. For instance, that actually gives us some performance benefits. It's a really nice feature. It's caused some interesting times for us, but I think we've done quite well with that. So let's see, what else? Okay, so that's pretty much all of the content that I have. I want to open the time for you to ask questions, have comments, that sort of things. Before I get it, I want to talk a bit about the story contents. If you go to Facebook and look at the RavenDB page, we now have a context where we want to hear your stories. What have you done with RavenDB? How it made your life easier? What sort of experience you had? We're actually going to send the first 50 people some t-shirts and some really nice stickers that we have. And we're going to offer some training DVDs among everyone who sends the story. So with that said, let me go and talk about the questions that you have. So Troy Zarger is asking, with all the new performance enhancement in 2.5, what kind of write statement, write performance could you expect in a heavily write application compared to 2.0? That mostly depend on the sort of writes that you're doing. The worst case scenario is that you have a single threaded application that's write one at a time. For that sort of a system, we haven't done much. I think that the performance at that point would be between 3 to 5% improvement. Probably, yeah, something around that. You would see some improvement with regards to indexing spin under that scenario regardless. The more common scenario of you have multiple threads writing at the same time, and this is the common scenario for something like a web application, that's going to see more major improvement. I would be surprised if we wouldn't see 20 to 25 percent performance improvement over 2.0. Mostly because we remove the contention, mostly because we remove, we now allow you to do indexing without touching the disk. So that's the sort of numbers that we're talking about at a minimum. If you care about performance with RavenDB, the general recommendation remains the same. Get an SSD and split the writes into multiple separate physical hard disks. That means that logs go on one disk, indexes go on the other, and the actual data goes on the third disk. What is the actual improvement regarding DTC? Asked by Crystal Telly. So the DTC improvement includes better adherence to the protocol with regard to after the prepare statement is called, we at the same time we also apply all of the triggers. We actually reserve all of the space on the disk, and we do another thing. And we defer the actual commit, the actual physical commit. The reason for that relates to the sort of promises that you have to make for the DCC protocol. That actually was a performance decrease, so we actually had to spend some time optimizing that scenario. Mostly around the way that we work by default with regards to volatile versus durable resource managers, and with regards to how we handle internal implementation details of the DTC protocol. Something that I want to talk about with regards to DTC, I hate it. It's complex, it's brittle, and it's really annoying to work with. So if you can try avoiding it, you would have much easier time overall. Trust me, it's just so annoying to work with. Anyway, more questions, comments, stories. While we're talking, I want to mention again, in a couple of weeks, we're going to do the start of hopefully many webinars about RavenDB 3.0. I know that we're now just releasing 2.5, but we already actually started working on 3.0. We have some really, really nice things to show you for the next version of RavenDB. So please sign up for the webinar. We have a limited space there, and show up and hopefully see some really, really cool stuff. I'm going to give you another few seconds if anyone have any questions to ask. If not, we're always available at the mailing list. And that's it, guys. Oh, no. Boris Simonov, who has asked a question at the very last minute. Is there a sample application showing 2.5 features? The answer is that to a certain degree, yes. I would recommend that you go and look at the RavenDB. And that is a really nice application demonstrating some nice features. So RavenDB, this is by Simon Bartlett. I had a nice review of it a while ago. It mostly is focused on showing spatial features, but it also shows some usage of things like bulk insert and stuff like that. Steve Gorley is asking, was the indexing type that was optimized for many write like in a login scenario added in 2.5 or earlier? I don't think that we ever had an indexing type for many write. I think you're talking about the bulk insert feature. And if you're talking about the bulk insert feature, that was added in 2.0, and pretty much like everything else optimized and worked on in 2.5. And any additional questions? Going once, going twice, and that's the bell. Okay, guys. So thank you very much for showing up for the webinar. I will hopefully will have it posted on YouTube in a short while. And goodbye and have a great weekend.